must take some more complex algorithm and principle. So this experiment demonstrates us that with a very simple example, that the physical modeling was a very good, very relevant way. And at this time, that is exactly near the beginning, we conceive the simulation as something which must be modular. That is, because the user must not have to create its algorithm at each experiment. Let me show you now one of the first force feedback transducer built in 1981. This is a K with the sizes of a piano K, and of course we can see that we need a sensor. Two sensors, in fact, on this one, a force sensor and a displacement sensor. And, it's very important, another device, which is a motor, to create the force interaction, the force feedback from the computer to the user. Let me show you this very simple first experiment that shows that without any sound and any images, this idea of force feedback and tactile sensation. In the computer, we simulate a very small, very simple object made with a spring, a little mass, and this object is manipulated through the K. And we will see three examples with first low stiffness in the K, second high stiffness, and third a pure damper, that is no stiffness. This experiment was very important at this time to make understanding, to explain what is this concept of force feedback transducer and what is this concept of tactile perception. In fact, the tactile perception is very complex. We must say, in fact, tactilo-proprio-kinesthetic perception, which is a very complex senses for human being. Before this K, in fact, Jean-Luc Florent built the very first TGR in 1979. He took a motor from his washing machine here, because we have no money at this time to buy something complicated. And we have two devices here, which clutch like car, which clutch the movement of this motor to these two axes. And in order to move this part. If I can't, but my English is very poor, so maybe I will have to explain something in French. And I apologize. Here we have the force feedback sensor, and here a displacement sensor. This device was very simple, very rough, but in fact it has already very good performance. For example, time response of 1 millisecond, and it allows us to verify some important hypotheses, the importance of feedback, and also in the question of interdependence between several senses, for example, between the tactile sense and the sight and hearing. Here is the first simulation in real time by NIME03, combining force feedback transducer and physical modeling to create animated images. This is a small punching ball, and in our finger we can feel the interaction with the ball. Now, more about force feedback transducer. In fact, the technology of force feedback transducer is complex because it's a very complex question. The gesture channel is very complex. First, of course, we have to consider two components in order to support the two directions of interaction. Sensor to sense the information from the user to the computer, and conversely the effector, which are generally motors, to communicate from the computer to the people. And several criteria are important. So, for example, the number of degrees of freedom. You know that our hand, we have with our hand we have 23 degrees of freedom. See, the bandwidth of communication, at least 1 kilohertz, but very often more. So, range and resolution of phenomena. We are able to sense 1 micron of displacement in our finger, and the forces must be very strong. We evaluate at this time that in certain situations, for example, when I struck a rigid object, we receive forces in our hand that may reach several hundred of newtons. And another difficulty in force feedback transducer, different with other transducer like loudspeaker or screen, etc., is that it is not possible to design a universal system usable for every situation. We have to consider with what object we interact, for example, joystick, etc. And it was also a very important question to solve. In 1988, we built the first modular system, the clavier rétroactif modulaire, which comprises two modular concepts. First, this slice motor, which is a patent from Acroe, which allowed to have a very good performance, particularly strong force feedback in very compact volume. And second, this concept of morphology, variable morphology, in French habillage. Habillage, for this device we had in order to adapt the space of this basis of motor and sensor to the kind of manipulation we want. For example, a 2D joystick, a piano keyboard, players, and two 2D joystick, for example. Now, concerning the modeling and simulation language, we start with this reflection and research on a modular system in 1981 when we developed the first version of Cornice Anima. And the idea for this system is to generalize, to propagate inside the machine the concept of interaction at the macro level between the user and the machine, and to consider that we will build physical object, by putting together an interaction